The halogens are the elements in group 7 of the periodic table. They are fluorine, chlorine, bromine, iodine, and astatine. Halogens in their elemental form are toxic, though their compounds have many real-life applications. The halogens all have 7 electrons in their valence shell and can accept 1 electron to form an ion with a -1 charge. Moving down the group, atomic radii increases by 1 electron shell. As a consequence, melting points and boiling points and their density also increase. To illustrate this, fluorine and chlorine are gases, bromine is a liquid, and iodine and astatine are solids. Fluorine is a very pale green gas. Chlorine is a greenish-yellow gas. Bromine is a reddish-brown liquid. Iodine is a gray solid that sublimes to a purple vapor. Astatine is a black solid and radioactive. Moving down the group, the reactivity of the halogens decreases. So a selected halogen is always more reactive than the halogens below it. A more reactive halogen will always displace a less reactive halogen in a compound. We will demonstrate these displacement reactions using aqueous solutions of potassium chloride, potassium bromide, and potassium iodide. Note that these are all halogen-containing compounds. When we add chlorine water to an aqueous solution of potassium chloride, no reaction happens. Since chlorine is more reactive than bromine, chlorine will displace bromine in potassium bromide, producing potassium chloride and liberating bromine. The resulting solution is reddish-brown due to the presence of bromine. A similar observation occurs when chlorine water is added to an aqueous solution of potassium iodide. Since chlorine is more reactive than iodine, a displacement reaction will occur to liberate iodine according to the reaction below. A dark brown solution is produced due to the presence of iodine. Let's predict what happens when bromine water is added to the same 3 aqueous solutions. Please pause the lesson to think about this and resume once you are done. When we add bromine water to aqueous potassium chloride, this causes the solution to turn reddish-brown, but no displacement reaction occurs, as bromine is less reactive than chlorine. No reaction occurs when bromine water is added to aqueous potassium bromide. As bromine is more reactive than iodine, it will displace and liberate iodine in potassium iodide. Therefore, a dark brown solution is produced due to the presence of iodine. If we added iodine to the same 3 aqueous solutions, no displacement reactions occur, as iodine is less reactive than both chlorine and bromine. Halogens can react with certain metals to form metal halides. A very common metal halide is sodium chloride or regular table salt. Sodium chloride is extracted from the sea or from salt mines. Sodium chloride can be produced from the reaction of heated sodium metal with chlorine gas. Since it is a highly exothermic reaction, it is not recommended that this be done in a laboratory. Halogens can react with hydrogen gas to produce the corresponding hydrogen halide. Most of these reactions are also highly exothermic. As an example, chlorine gas and hydrogen gas can react to form hydrogen chloride. In summary, the halogens are the group 7 elements. Their displacement reactions involve a more reactive halogen displacing a less reactive halogen in a compound. Halogens can also react with metals to produce the corresponding metal halides and can react with hydrogen to produce hydrogen halides.